Right. Welcome to the laboratory. I'm Joe My Goodness. Today I'm going to take you through the triangle detection app that we've built for measuring what our equilateral expedition is up to. So I'm going to go ahead and launch it here. Hopefully everything is going well today. Good. Okay, good. There we are. We can see that we have a picture of the piece right now. If I want to, I can go down here and I can put it in live preview. It's a little slow to update, but you can see that it's running a plasma pattern now, I think written by Z Ranger. Thanks, Z. So, yep, that's stepping through. I'm going to just turn that off for the moment, save some resources. And you may notice there are a lot of tabs on this. We've been working on it pretty hard. First, I'm going to go over to the PixelBlaze tab. I'm going to wait a moment here. I'm going to find when the devices load. I'm going to go to R control and connect. Okey-doke. So now I'm connected to that device. And that PixelBlaze is the one in charge of the 7 that you saw previously. So what I'm going to do now is go to our calibration pattern, and I will go ahead and deploy that to the device. Now, hopefully, when we go back to our live tab, if we turn live preview back on, there it goes. Okay, so now we can tell which way every triangle is pointed at a glance. So the green corner corresponds to where we have the sensor located on each of the boxes. Why does this matter? We're dealing with robotics. We need to know exactly where every box is and at what time. Furthermore, we need to be able to prove that we have deterministically created code which is executing the way that we expect it to. So to do this, we're going to figure out exactly where each box is at any given time. And to make it more challenging for myself, I'm just going to go up here and I'm going to create a playlist to put them in a difficult position. So let me do that. Okay, so run playlist, add to playlist. Okay, so first thing I'm going to do fast align. Go ahead and add that there. That will snap all the boxes into position. Next, we're going to do lower tier. Sorry, it has to do with points, I remember. There's a lot of patterns. Ah, there it is. Lower tier points out. Add that to the playlist. Then we're going to go lower tier linear lock. Okay. So I'm going to go ahead and get that started for now. Okay. We're still recording. I'm going to go ahead and now go over to the installation. And we're going to show that this is not just smoke and mirrors. See here, we're going to flip the camera. Perhaps not. Alright. Just stand here with it. In selfie mode, I guess. So it's running through the alignment phases right now. We have achieved equilateral nature. Next, we're going to rotate the lower tier boxes so that the points are faced outward. Yep. Now we're going to move these lower tier boxes inward so that they're somewhat overlapping. Okay, that's it. That's all that does. Okay. So why did we do this? Because it's hard to detect boxes that are on top of other boxes. So still recording. Great. Now I'm gonna actually cancel the action here. What the software is trying to do is analyze pretty much everything we do. I just have it set up to, you know, go and analyze the video of what we did and try to match it up. But we're not quite there yet. We're still trying to get ourselves in alignment. So now if I do live preview once again, you should see, yep, things are lined up pretty well. But these boxes are overlapping a bit, which we found to be very hard to detect. So we've built a filter for this. And luckily it's already pretty dialed in at this point, so I'm going to just hit capture and detect. Wow, look at that. Okay, so it's pretty good, but it's not doing perfectly. And the reason for that is that it's very bright today. The lighting matters. So we have built an offline machine learning algorithm to handle this kind of situation. So what I'm going to do is I'm going to take the little corners of these boxes and retrain them and say, nope. Oh yeah, by the way, this is the 12 o'clock box, this is the 2 o'clock, 4 o'clock, etc. And then this one is the center box. So now these triangles are looking pretty good. That's just about right. We can also see that we have these cool position filters. And this is sort of where the magic happens. So if I were to change like the outer zone position, so right now it's 106, I'm going to change that down. You see how much those boxes move around and their detection changes depending on that, right? So let's carefully put it back to 106, where it was pretty good. And then unfortunately I need to retrain, but that's all right. We're showing that this is in fact a demo. Okay, that's pretty close there. So I think my lighting settings are close-ish, but there we are. We're going to see how we did. If I can remember how to do it. It's been a minute. So I think I want to retrain geometry. That's it. Okay. So then it runs a sweep and it posts into the results. All right. So if we scroll down, I believe, to the bottom. Okay, so we can see what we're detecting now as is. And we can see all of these different options, right? So we know that the inner zone, I didn't really talk about that, but that's just for the center box. If we set our position, which is like the level of brightness, versus the bloom to these levels, it would be optimized. This is our next best, and these are arrived at by iterating through thousands of options. Again, offline, we're not using any AI tokens to do this part. So this is just running Python CV library for those interested at home. And then down here, yeah, we have our outer zone. Similar, so 55-35, is that the same? Yep, so pretty much the same for that. You might notice the next position though is the second best is 65-35 there, but 85-35 there. So I'm going to just apply the best of both worlds there. And now if we go to live and we do capture and detect, as you can see, it's doing a better job finding those darn triangles. Why does it matter? Okay, here we'll turn that position off. And are we live previewing? Now we are. Okay. Everything matters. So what we're going to prove now is that we can once again fast align, and I want to just show off pretty much our best playlist at this point. which I think we're calling it full attract v2 add to playlist. Okay, so this is our playlist. Go ahead and run it. So we're gonna walk the camera back over. Make sure we're still recording everywhere. Good. It's pretty satisfying when they actually go somewhere. And then, yeah, here's the Kinect sensor we have pointed at it. Alright, so you may notice a couple of these boxes have relaxed now. We turn them off when we're not using them. That helps conserve power and prevent heating issues. And yeah, call out. At this point I'm going to cancel the action that we've started here. Again, it's trying to analyze the video, and we don't need to do that. We've run hundreds of analyses. So I'll actually go to the results tab and show you a little bit of our massive library. Oh yeah, okay, so you can see we've done at least 300 takes, and we save each one. So this is 24 frames per second. We're capturing and analyzing. So I think this one might be good to load. Take 300. Yep. And I'll just show you a little bit. Okay. Sorry, this little UI is kind of in the way here. Let me see if I can stretch it out for you. I know I put a handle on here somewhere. Not that one. Nope, not that one. Alright, well at any rate, I need to get rid of this little resize dialog here, but we capture and analyze everything. So this is showing for each box their relative movement as best as we've been able to detect it. And so down here, we're able to replay the animation. So there you can see what we're expecting it to do and what it's actually doing. So you can see we're still only running at about 50% speed. I can get rid of the Kinect frame and the actual schematic, and yep. So this is what we expect the boxes to be doing. And then this is what we've detected them doing. So pretty close. You can see it jitters a bit, but again, it's to a point where it's actually useful because we've been able to compare the waveforms, we've been able to compare the length of these various sine wave movements and get things dialed in better. It also helped us determine that we just needed some better hardware. We were reaching a bottleneck with the motherboards where each motherboard was reliable up to running 2 motors. And if we're running 13 motors across 3 motherboards, that doesn't add up well. So we've upgraded to the Pro version, and it seems to be holding together much better now, with about 3 times the cycles available. So yeah, that's the power of data analytics. We've also got this really cool Insights tab where I can go through and say, hey, for each of the last n number, I just do 5 usually, of, what did we decide it was? It was full attract. Yep. Let's run query, and there you go. You can see what it thinks our time ratio is. That looks like a mess. I do recall it was only, I think there was a bug in it I had to fix. So let's try running that again, just with 1. Let's see if it's better. Not really. Yeah, I remember it was only capturing about 10 seconds of video in the latest iteration. But regardless, this was telling us, hey, our time ratios were offset this much. So with that information, we were able to very precisely back model what we needed to do, or back propagate into our extraction model. So all of this is built at the core from some Blender animation. So if I open Blender, you're still here. We can see, yeah, this is the animation it's based off of, right? So these are the boxes moving like that, and then it loops around basically. So this is what we're going for, and we built a Python extractor that essentially takes the output of the top box here for the, let's see, the green line, which is Y. So how much it's moving in the Y-axis in millimeters. And then we also extracted the rotation of the Z-axis, so how much it's spinning like a top. And then we did the same thing with this pink box down here. So those 4 lanes of data, we just output to basically an Excel document, a CSV. And then with those, 540 frames of information across the 4 channels, we have assembled our new G-code, which is running our software basically like a printer. So the other way we could look at this is if we go to Klipper and we go to our G-code files, we can see all of the G-code files that we've uploaded here. And then, of course, our machine has a custom printer config running our various motherboards here. And then, yeah, our various lessons learned and comments as to why these things are the way that they are. If we go back here, back one more, refresh, I can go G-code files, and I could just run like the fast alignment from here the old way. And you can see that it's quote-unquote printing. So basically we have taken components of a 3D printer and then warp them to our interesting design here. One downside to our model is that we can't use like the G-code viewer or standard Cartesian coordinates because we aren't dealing in squares, we're dealing in triangles. So that's been a big challenge for us, is to sort of remap the way we're thinking about extracting G-code. So yeah, I hope you enjoyed this incredibly long discussion. Oh, I guess I could talk about the other tabs in the last few moments here. There's also a Perform tab, which basically won't run any of the analysis. I could run this from my phone or any device on the network. I just have to give it permission via the host computer, because I don't want anyone just hacking in here who shouldn't be. And then we also have this cool monitoring setup, so I could just start monitoring if I wanted to, And now it's monitoring my CPU cores and how hard everything is working, you know, graphics card wise. I was working on some optimization of the analysis, so got to analyze the analysis, you know. I think that's all it does. Yep. Yeah. Again, thanks for sticking around for this entire demo. There's a few more features I guess I didn't really talk about. I can update from here. I can do a what's new walkthrough. There's a release archive, so I can see what all the features were when. Can stop the server at any time. And all of these have contextual help links, so I can at any time that I forget what it does, go through here and see what the things were. So again, thanks for your interest in our project.